Hello, and thanks for joining me for today's webinar, Adapting Your Network to Today's Video Demands Without Going Bankrupt. My name is Fred Clark, and I'm the founder and president of Video Conferencing Technologies, the sponsor of this webinar. Let me give you an overview of today's presentation. First, we're going to be talking about the power of video, and more specifically, video conferencing. And it is very, very powerful. Number two is the effect of video and video conferencing on your network. And any video takes a significant amount of bandwidth, and so it does have a significant effect on your network. And number three is tying the first two together and presenting viable ways of implementing video conferencing smartly and economically with a network design that is robust and ready for the future. First, let me give you just a little background about myself and how I got interested in telecommunications and more specifically video conferencing. I grew up in Norfolk, Nebraska, went to school, went to college, and then I asked my dad if he would hire me. My dad and his brother owned a general commodity truck line in northeast Nebraska. He was delighted, like any father probably would be, and so I ended up being the terminal manager in Sioux City, Iowa. Now, when you work for my father, you really started from the ground up, and so I basically became a truck driver. We had a very small office when I got there. We had 3 people. When I left, we had 6 people, so we were really small. Very soon I discovered we were also very inefficient because this was back in the day before cell phones were invented, and when you're in a truck, you have no way to communicate with the other drivers, and so trying to coordinate the 3 of us or 6 of us was completely impossible. One of the first things I did was decided that just wasn't going to work, and I bought commercial two-way radios and put them in all the trucks. That really helped. The second thing I did was I hired an answering service that was tied in to a commercial two-way radio tower, and I got a Bell & Howell two-way radio, wore it on my belt, similar to how you would use a cell phone today, except this was 5 or 10 times the size, but it worked. Our calls would come in to the answering service. They would page them out to me on my Bell & Howell radio, and then I would dispatch them to the other trucks with our truck radios. Worked great. We went from being very inefficient to being incredibly efficient because of communications. That sold me on telecommunications. A few years later, I decided that it was time to make a change. This also helped lead to my decision. I was really looking for more of something like this. And maybe even this. This looks good. But then I thought of my wife and daughter, so I settled for this, and it was a good choice. So the next thing I had to decide was, what am I going to do? I need to make a living. So the only thing I could think of was I wanted to do something in the telecom area. I could see how much telecom changed and improved my business, and I wanted to do the same for others. So I got a job selling telephone systems. I did that for a couple of years, sort of learned that business. I then started a company called Amtel Technologies. In the beginning, we sold call accounting equipment to hotels. Later, got involved in complete telephone systems, and even later, we became developers of a variety of products in the public communications sector. We dealt with hotels, truck stops, prepaid calling card platforms, cruise ships, payphones, and just a variety of things in the public communication sector. A little bit later, we started a company called Audacity Audio, and Audacity Audio designed audio applications for smartphones. And then a few years ago, we started video conferencing technologies, focusing on video conferencing and also the network design that the video runs on. So on with the presentation. The power of video. People remember 30% of what they hear, but 80% of what they see. I've seen this quote several different places. I gotta believe that it's true. When you relax at night, do you watch TV? Do you listen to the radio? Well, you watch TV, or most people do anyway. Why do you do that? Because TV is just much more powerful, much more engaging an experience, and radio has its place, but it's just not as powerful when you have a choice. One of the reasons 60% of communication is nonverbal. So the more stimulus you get, whether it be visual or audio, the better off, the more comfortable you're going to be, the more engaging the media. And when it comes to one-on-one, I don't think the telephone does a bad job. I think the telephone is pretty good. It's not as good as video or video conferencing, but it's not bad. But when it gets into multi-party, if you're having a conference between 3, 6 people, the video just adds a whole lot to the experience. Overall, video is incredibly powerful. Video conferencing results. These are just some statistics that I've gleaned from various readings and webinars. Saves 30% of travel-related costs, lowers time to market by 24%, reduces training costs by 25%, trims recruitment times by 19%, and shrinks sales-related costs by 24%. Pretty significant productivity increases. I know from my own experience, I work with people all over the country, and it certainly has made my work experience more productive. Where is video headed in the future? Well, video conferencing is expecting a compound annual growth rate of 19% between 2010 and 2015. Pretty significant. Immersive video conferencing, in other words, sometimes it's called telepresence or high definition video, high quality anyway, grew 24% in 2010. Also in 2010, video conferencing was a $2.2 billion industry, but by 2015, Infinetics says it's going to be a $5 billion industry, and Gartner is even more optimistic, saying it's going to be an $8.6 billion industry. Currently, nearly 2/3 of websites include video, and by the end of 2012, video is expected to exceed half of all internet traffic. In other words, I'm saying on this slide, video is rapidly expanding. Be prepared. The effects on the network. The average YouTube video is equivalent to 500,000 email messages. Now, I have read that. I find that statistic hard to believe, but I have read it. In 2010, the average wired internet user used up 20 gigabytes of bandwidth. By 2015, this same user is expected to use up 140 gigabytes of bandwidth. In other words, a 7-time increase in 5 years. On the wireless side, it's supposed to be a 38-time increase in 5 years. It's not just video that's clogging up the network, but also telecommuters. 20% of employees work from home at least one day a week,
and 13% work from home every day of the week. But not even just telecommuters, it's also cloud computing, the virtual office, mobility, social networking, and the list goes on and on. Basically, video, as well as a lot of other things, are clogging up the network. The network cost. I've seen studies that conclude the need to increase the cost of a video conferencing proposal by 30% to cover additional bandwidth needs. Now, I disagree with that premise, and I'm here to prove my case. But before I do that, I want to take just a little short seventh inning break. And in keeping with my cat pictures and my cat theme, I'm going to play this short video clip. Take a look at the network and the different types of traffic on the network. There are 3 or 4, depending on how you look at it, different types of traffic. But the most common is data, which includes things like email, web surfing, file transfers, and things like that. It's based on a TCP protocol, which is a guaranteed delivery protocol. If there are network problems, packet loss, congestion, etc., the protocol retransmits anything that's lost so that when it gets to the end, everything is okay and you're happy and fine. It does, this retransmission slows things down a little bit, but as long as it doesn't do it too much, you don't know the difference and you're happy with it. Voice is another story, and voice and VoIP is another story. It is real time. It can't retransmit, and so it's based on a UDP protocol, which is a best effort protocol. If we get these same packet loss, congestion conditions, you get things like dropouts, you get unintelligible audio, and you complain. And certainly the carriers realize that, and your tolerance for poor audio is very limited, and they realize that, and they do everything in their power to prevent that. On the LAN side, they put in VLANs so that it separates the voice from the data. On the WAN side, they put in QoS mechanisms. They require a T1 so that they can manage the circuit end to end. And sometimes they separate the WAN link into a data side and a voice side, and if you're not using the voice side, it just sort of sits idle because they want to guarantee that if you're going to make a voice call, it's going to be good and you have enough bandwidth to do it. Video, the biggest characteristic on video is it's very high bandwidth. There's one-way video, there's two-way video. One-way video is like a webinar or a YouTube video. There's a receive buffer, there's a playback buffer. The receive buffer receives the data from the network. The playback buffer then plays it. And as long as the receive buffer can stay ahead of the playback buffer, no problem. But when there's network congestion and the receive buffer gets smaller and smaller and the playback buffer starts catching up with it, and when it does catch up with it, it stops the playback, waits for the receive buffer to fill up again, and then it starts playing back again. A little bit annoying, but it works. Two-way video is more challenging. It is very high bandwidth. It is also real-time. It's very similar to VoIP in that it uses a UDP protocol, which is a best effort protocol, And so the real challenge for the carriers is, how do I provide good video, which is very high bandwidth, and still maintain a high quality? Well, most of them use things like MPLS network, where they can provide a QoS experience, and that is quite expensive, but it works, and people are happy with it. The video, good quality video, starts at about 500 kilobits per second, and it can go all the way up to 4 megabits per second. Whereas with VoIP, it's 100 kilobits per second at a maximum, and probably more like, most people figure, about 80 kilobits per second. So those are the different elements of transmission on your network, and we'll cover more about that later. Now I want to take a look at the video codec. All video conferencing is based on a certain codec. The ones that I have listed here are the standards-based codecs that are used really by all of the common video conferencing vendors. There are some non-standards-based ones that are in use, the most notable one being Skype. But the normal video conferencing vendors that you would think of all use standards-based codec, at least one, and many times they use multiple codecs in their solutions. The first two are older ones, the ISDN and H.263. That's an IP-based one. It's older. You don't see too many of them in the market anymore, but still a few. The newer ones are H.264, and there are 3 different standards based around the H.264 codec. The first, and also the most common, is AVC, which stands for Advanced Video Coding. I would say all of the major video conferencing vendors use this, and many times others as well. A little newer standard is the high profile standard. The main claim to fame for high profile is that it can do HD video on less bandwidth than AVC. If you have a high profile endpoint on both ends, you can get by with less bandwidth. The latest codec is the SVC, which is scalable video coding. It was designed to be used on a consumer-grade network, and that was its purpose from the start. All of the codecs in the past really required a QoS network. In today's world, that's called an MPLS network, but certainly some type of high-quality network to get good results. Scalable video coding is designed for a consumer-grade network, which equates to a cheaper, less expensive network. The engineers behind the scalable video coding were industry veterans. They were commissioned to come up with a new standard, and they liked the standard so well that they quit their jobs, created a new company with its sole mission is to develop a complete product line based on the scalable video coding standard, and that company was called Video. Let's take a look at some of the trends in video conferencing. In the past, it's been primarily used in the enterprise, certainly larger companies, and really conference room to conference room, used internal, between remote offices. It's primarily used H.264 AVC, a little bit high profile, but mainly AVC, and it's run on an MPLS network. In this scenario, it works quite well and is quite useful. In the future, it's going to be used more in the smaller companies,
It's certainly migrating to smaller companies and even individuals. Still will be used in the enterprise. It will be used room to room like it has in the past, but it will also include telecommuters, desktop users, mobile users, on your iPad, on your Android device, and it's also going to be used a lot between companies instead of internal within one company. It'll be used between companies, and it'll be used on consumer grade networks rather than MPLS networks, because when you start adding in everybody, that's the only practical way to do it.
Just how you feel. You got to roll with the punches and get to what's real. Can't you see me standing here? I got my back against the wrecking machine. I ain't the worst that you've seen. Can't you see what I mean? In the future, video conferencing will be an any-to-any model. In other words, any device to any device, any company to any company. It will not be the old model of room to room within a company. It'll be an any-to-any model. It'll run on a consumer grade network, and it'll do that because it's not practical to run an MPLS network everywhere in the country, because on an any-to-any model, you got to take what you're given, and that's going to be a consumer grade network. It's also much cheaper to run it on a consumer grade network because an MPLS network is really expensive. I've heard that it's 100 times more expensive than a comparable bandwidth consumer grade network. Now, I tend not to believe that. I think it's more in the realm of 10 times more expensive, but at any rate, it's much more expensive. And so in the future, it's just not going to be practical to do it, because of the expense and also just the practicality of an any-to-any model. I'd like to make the case for video, and I have to disclose that I am a video vendor, so I am somewhat partial, although I have a good reason to be. Number one, these are my 8 reasons that my top 8 reasons that I like video. It's based on the scalable video coding, and I really think that the market of the future is an any-to-any market, and the only viable, or certainly the best viable codec for that market is the SVC codec. It was designed for that market, and it's the only thing practical to use in that market. And who better can do it than the founders of that codec, and they certainly have a head start in that market. All of the there are other vendors that are now interested in SVC, but their interest really has only come about in the last year or two, and really only have come about after video became successful with that codec. Number 2, they have a complete product portfolio, all based on the SVC standard. It ranges from the Apple products, the iPhone, the iPad, Android products, desktop, both Windows and Apple, and room systems, high-end telepresence systems. They have a really nice high-end system called Video Panorama that can go up to 9 screens. Eventually it'll go up to 20 screens. It does 1080p, 60 frames per second, two-way video, incredibly high quality at a very reasonable price. All of their product is high quality. Everything can do HD quality. I do demos on my Windows-based PC. Now it's a good PC, and I know how to do it, but I get very high quality, and people are amazed when I do a demo at the high quality of it. Interoperability, although it's not so much of an issue today, in the future that will be a key differentiator in product. The model will be an any-to-any model, company to company, and that'll happen gradually, but it will happen. Video is very well prepared for that model. They're actually one of the most interoperable products that I'm aware of. Everything is very easy to use. It's web-based, has a consistent interface, an easy-to-use interface, quite nice. It's based on a really nice cloud architecture. Uses off-the-shelf hardware, so it's economical. The center point is a router rather than an MCU. In most video conferencing infrastructures, the central point is an MCU, and sort of the heart of the system is an MCU, because when you get multiple endpoints, they all have to talk to one central point, and that point in a typical video conferencing system is called an MCU. The MCU has some major challenges. Number one, it has to bring in all the data from all of the endpoints, has to decode it all, has to mix it, and then it has to encode it, send it on its way. That's a lot of data and a lot of processing, and here's the problem with it. Number one, the decoding, encoding degrades the signal. Number two, all of that heavy-duty processing takes time. That causes latency. That's a problem. Number three is the expense. All of this heavy-duty processing takes a heavy-duty processor, which is very expensive. With the video architecture, the center point is an application layer router. The throughput is about 20 milliseconds. There's no encoding, decoding, and it's just a much more economical choice. The last point is that video has a great reputation. They haven't been around very long, or in longevity standards, I guess, but in that short period of time, they've achieved a great reputation. Case in point, I watched a webinar a few months ago from an industry veteran, and he has a competing product, but he commented about how he really liked the video architecture. Now, that's pretty good from a competitor. Now another short kitty break. Video conferencing technologies. Who are we? What do we do? Number one, we're a video conferencing vendor. We're a video reseller that we mentioned before. We also have a hosted services platform based on the video architecture. We really like Hosted a lot. We really like video conferencing a lot. Think it's incredibly useful. And being able to both resell product and provide services around product is very nice. We like the flexibility to do either. So we can accommodate all customers, all types of customers, no matter whether they're large enterprises to small individual users. One of the other things that you can do with Hosted is provide a hybrid service where the customer buys part of the infrastructure where it makes sense, and we host the balance of the infrastructure where that makes sense. We also have several networking products and services. We offer a whole host of carrier type services, and there are also some specialty services that we get involved in as well. Three of those that I've listed here: Apneta, Exinta, and Elphic. The first two are visibility products, and Elphic provides a load balancing product, and we'll get into the details of those in subsequent slides. Apneta is a visibility product. We got involved with Apneta to begin with through our own needs and experience. We were experiencing some network problems and things that we just couldn't understand. Why is this happening? Why is this degrading? We just were lost as to trying to figure it out. And what we needed was a visibility product, and we settled on Apneta. A consumer grade network is different than an MPLS network in that the network is up and down, and a consumer grade network is anything but stable. An MPLS network is very managed. It's very expensive, but it is managed so that supposedly anyway there are no major spikes and you get a consistent quality of service. With the consumer grade network, that's not the case. We needed a way to figure that out, what was happening, and the Apneta product really gave us some really nice visibility into that. You can use it either for WAN problems or LAN problems, or LAN and WAN visibility. We primarily use ours in the WAN because that's where we're having problems and wanted to see what was going on. You can set violation thresholds. For instance, ours is set to trigger a violation if we have a certain length of time where we're over a 2% packet loss. If we exceed 90% capacity on a link, it will trigger a violation. And when it triggers a violation, we get an email. We get emails sent to us once an hour that tell us all of the violations that happened with any of our probes that we have out in the field. And these violations tell us when the violation happened, what it was, how long it lasted, when it was cleared, etc. And we can customize all of these thresholds to meet our needs. A couple other things that we can do. One of them is provide load testing for voice and video calls. Being a video conferencing vendor, we're primarily interested in the video side of things. And we have run tests on our own network. For instance, we ran a test of 2 streams of 768 kilobits per second for each, one to California, one to Miami, and they worked fine, didn't show any problems. We then started increasing that, and it was really interesting to see the network degrade once it reaches its capacity. And you can put these tests in pre-deployment, post-deployment, leave them in all the time, run them just for a couple weeks. Really nice to be able to do that and see what's going on. And having the ability to do that prior to an install so that you can, adjust if there's a problem. The other thing is application awareness. You can see who's using what application for how long, when. Very nice to be able to look into statistics like that. And you can get an overview of the problems. You can also drill down into the problems to get a granular view. Exinda is another visibility product. I consider it an active product, whereas Apneta I consider a passive product. By active, I mean not only can you see what's going on, but you can control and optimize it as well. You can link it to Active Directory, which I find to be very nice. For instance, if I see that Mary has, I can check Mary's activity. I see that she's downloaded a YouTube video, and here she's been on Charles Schwab. She spent a lot of time on Charles Schwab. Now, that's probably not a business-related activity, and so if I want to, I can slow down her use of that. I can stop it altogether. I can control her access and activity completely if I want to. One of the other things you can do that's really nice is between a headquarters and branch. You can optimize the traffic. Let me give you an example of that. Let's say that there's a routine that's used by everyone in the branch, and this routine resides on the server at the headquarters. Rather than downloading that each time somebody uses it, you can cache that routine at the branch, and then when somebody wants to use it, it doesn't have to traverse the network because it's already at the branch. The application works just like always. It's just that it reduces the network traffic. Before I get into ELFIC, I'd like to talk a little bit about redundancy. In the networking world, redundancy is always a positive term, and certainly that is also the case in WAN design as well. Having a redundant WAN link, I think, is critically important. Carriers tell you that their service is the greatest in the world and most reliable, etc., but nobody's immune to problems, and having a redundant link and redundant carrier completely, whether it's a single redundant one or multiple redundant ones, is really comforting and I think critically important. Assuming you go that route, load balancing is really the icing on the cake. You can load balance both inbound and outbound. This is where ELFIC comes in. You can have automatic failover. If one link fails, it'll automatically go to the other link, and when it comes, your primary link comes back again, you can split the traffic up again. You can put critical traffic over your MPLS circuit. You can put normal traffic over your cable circuit. Not only that, but you can create policy statements so that I can provide, let's say I put my voice traffic over my MPLS circuit, and I prioritize that so that it goes out in a priority queue. And on my cable circuit, I prioritize my SVC video as an example. You can also say that, okay, when my MPLS circuit gets 90% saturated, rather than totally saturated, I'll switch the next traffic over to cable. That's another type of policy statement. Being able to use an expensive circuit and a cheap circuit gets into the economics. You don't need an expensive circuit for 100% of your traffic. So send part of it, send your critical stuff over your expensive link and send your normal stuff over the cheaper link. You can save lots and lots of money, and that really gets into the economics of network design. Before we leave ELFIC, I'd like to give you a little diagram so you can see how it fits into your network design. In the lower right, you probably can't see this too well, but in the lower right corner of the screen is your LAN and your firewall, and then you have a connection into the internet, and that's where the ELFIC fits in. So you got one connection into there on the outside of your router, and then two connections into two separate ISPs in the cloud. So before we proceed, I'm going to play one last little kitty clip. In conclusion, let me summarize what we've covered. Video conferencing is very powerful. Embrace it. It will have a tendency to stress the network because it's very high bandwidth, but there are a lot of other factors that are stressing the network as well. So the challenge is, how do I implement video conferencing, at the same time harden my network, and the real challenge is do so in an economical manner. Well, the future of video conferencing is an any-to-any model. Any hardware to any hardware, any company to any company. Using an SVC solution is the only practical way to provide an any-to-any model. Video is a really good choice in SVC. They were the leaders, they were the founders, they have a head start, and they have some really nice product. On the network side, there are many network choices. There's T1, that's sort of the old standby, but it's expensive, it's a relatively low bandwidth, and there are probably better choices. Fiber is a great choice. There are consumer grade choices like DSL, cable, 4G, fixed wireless. Some of those you'll not be able to get every place, but there are many, many choices in networks and many different carriers. Would certainly recommend using redundant WAN links and redundant carriers. Your network is just too important to leave to a single link, single carrier solution. If you're going to use a redundant solution, load balancing really makes it work slick. You can use a high-grade link and a low-grade link. Your critical traffic, you can put in an MPLS link or some other high-grade link. Your normal traffic, you can run over a consumer-grade link like cable. Doing it that way is very economical and will save you big bucks because MPLS circuits and networking in general is very expensive. A visibility product works really well because if you can see a problem, you can fix a problem. And the last suggestion, let video conferencing technologies help. We have the expertise, we have the products, and we'd love to help find a solution for you. I'm not sure just what to call this slide, but here's my best shot. If you follow my suggestions, you'll be a happy cat. You'll be rolling in dough. You'll find a friend and multiply. I have one final thought. When you're doing a network upgrade in the future, resist the temptation to use a single carrier solution. A redundant solution makes a lot more sense. I want to thank everybody for joining me today. I hope that I've given you some good ideas and hopefully you'll find it useful. If you're doing a video conferencing implementation in the future, a network upgrade in the future, please keep video conferencing technologies in mind. We'd love to help. Thanks. Here's my contact information. If you have any questions or comments, I'd love to hear from you. Bye for now.